All right, section 2.8b, we're going to look at solving rational inequalities, really looking at graphing them out and using the graph to help us do so. So first thing I'm just going to review real quick is, what do you do when you are trying to solve a polynomial inequality? So we talked about how we're going to be looking at the zeros, we're going to be looking at our degree of our function as well as the end behavior. So when I look at this, first of all, I'm just going to go through these three. And let's say that, trying to figure out when our equations equal 0, when it's greater than 0, when that's less than 0. I truly think that by graphing it out and drawing yourself a little picture, it's going to be the easiest to determine that. So with my polynomial here, I can see that I'm going to have 3 distinct zeros. One of those zeros is going to have a multiplicity of 2. And so overall, I have a total of 4 zeros that are being used here. I'm going to have a 0 at 0. I'm going to have a 0 at -3. And I'm also going to have a 0 at +2. So that's based off of my function here. And so I am aware that my function here is going to equal 0 when x is equal to -3, when x equals 0, and when x is equal to +2. Those are going to be the 3 values where our function equals 0. To work this out, if I were to multiply all of this out, I would end up with a leading term of 1x to the 4th. The fact that 1 is positive means that my end behavior is going to be like a parabola, so it's going to be going up to positive infinity from both directions. I have the 0 of 3 just one time, so my graph's going to have to go through that. Oh, I'm sorry, I've got it, that's the one that's got the multiplicity to it. So that means that my graph here is going to have to come down and bounce off of our x-axis at -3, come back up, it's going to go through the 0 at 0, and then it's going to come back up and go through our 0 up 2. And now I have my end behavior going to positive infinity. So it's going to equal 0 at the points of -3, 0, and 2. Well, now we're going to look at, well, when is our graph going to be greater than 0? So it's going to be greater than 0 when we are above our x-axis. So I can see here that there are 3 different intervals of where this is happening. We're looking at the values of x that are less than -3. We're also looking at the values of -3 to 0. So we're looking at that second interval, followed by the interval of x being greater than +2. Now you might be asking me, why am I not just making this interval going from when x is less than 0? The reason for that is because when you're looking here, you're saying, when does f of x greater than 0? Well, at -3, it would equal 0. So that's why I have to break this up into 2 separate inequalities rather than writing it all as one. Lastly, then the second part here is, when is it less than 0? So I'm going to look at when it's below the x-axis here, and that's going to be at the interval for when x is between 0 and +2. So now we're going to take this entire concept and we're going to apply it to our rational functions. So here I have f of x is equal to x plus 4 over the factors of x plus 6 and x minus 2. What we're going to do here is we're going to look for a couple of things. When does f of x, when does f of x equal 0? When is f of x greater than 0? And when is f of x less than 0? So we're going to solve 3 different inequalities with this problem here. In doing so, you also have the option of making a sign chart to help you do so, and then I'll give you an idea of what that sign chart looks like as well. So starting out, I'm going to graph my asymptotes, which are at -6 and +2. So here's one asymptote at -6. Here's an asymptote at +2. I have a 0 at -4. So here's -4. If I wanted to find the y-intercept, that's going to be at -2. And so this is enough information for me to go ahead and graph this out. And then what I could also do here is figure out the other branches of this. And we're going to be values here as well as here. All right. So now, looking at this function here, I'm going to be asking myself, when does the function equal 0? Well, there's only one value of where it equals 0, and that's when x is equal to -4. That's the only 0 that we have. On the next part here, when does f of x, when is it greater than 0? So when does my function, when is it above the x-axis? So I can see that I have two intervals of where we are going to be above the x-axis. I can go from the values of x that are greater than -6 but less than -4, as well as the values of x that are going to be greater than +2. So here's our interval. When is our function going to be less than 0? Well, now I'm looking for when are we below our x-axis, and that's going to be at two separate intervals here as well, where x is going to be less than -6 and where x is going to be greater than -4 but less than 2. Now, what you also have an option to doing here is you can help yourself with all this too if you were to consider making a sign chart. The only thing with making a sign chart is there's a lot of different parts that you have to be aware of and you have to think through in order to get yourself to be real precise about where the values are. So I'm going to use a sign chart on this next one to kind of help us out. This one. Okay. So what a sign chart is going to do is it's kind of going to do the same thing. It's just going to help us graph out a function, as well as it's going to help determine whether it's positive or negative. So I have these four functions right here. What you do need to do is you have to find the critical areas. And so it's important that we find our vertical asymptotes. It's important that we find our zeros because that's going to be really helpful to us. So I know that my vertical asymptotes are going to be at -4 and +3. So I'm just going to put a little marking right here. So here we have -4. And so right here, this is going to be our vertical asymptotes. So we're looking at undefined values at -4. And at +3 is another vertical asymptote, and we're looking at undefined values there as well. We have zeros at 5 and -2. So -2, I'll put that right here. So here's -2. And this is one of our zeros. And then we also have one at +5. So now what these 4 points are doing here is they are breaking this line or a graph or number line, however you want to think about here. It's breaking it up into a couple different segments here. And you'll see that it's being broken up into 1, 2, 3, 4, 5 different parts. What I'm going to do here is I'm going to make a sign chart in between each of those parts to figure out, well, when does our function f of x, when does it equal 0? When is our function f of x greater than 0? When is f of x going to be less than 0? So those are the things that we're going to be looking for. Starting out with the left here. So what I'm going to do here is I'm going to pick a number that is less than -4. So when I pick a number less than -4, I'm just going to go with -5. Going back up to our function here, -5 minus a -5 is going to give me a negative. So I'm just going to put a little negative sign there. Going into -5 plus 2, well, that is going to end up giving me a negative as well. Down below, -5 plus 4 is going to give me a negative answer. -5 minus 3 is also going to give me a negative answer. If I was to do all the multiplying out of this, I would end up figuring out that if I take a negative times a negative divided by a negative times a negative, overall my answer is going to be positive. Looking at the next interval here, I'm going to pick a number between -2 and -4. -3. -3 minus 5, well, that's going to give me a negative answer. -3 plus 2 is going to give me a negative answer. -3 plus 4, well, that will give me a positive. and negative 3 minus 3 is going to give me a negative. And so now a negative times a negative is a positive, divided by a positive times a negative. Overall here, this is going to end up giving me a negative answer. Now we're going to take a look at the interval from negative 2 to 3. So pick 0. 0 minus 5, well, that's going to give us a negative answer. 0 plus 2 is positive. 0 plus 4 is positive. And 0 minus 3 is negative. So when I end up taking a negative divided by a negative, this overall part right here is then going to end up being positive. Next part, between 3 and 5, so I'm going to pick 4. 4 minus 5 is a negative. 4 plus 2 is positive. 4 plus 4 is positive. And 4 minus 3 is going to be positive. The overall effect that's going to take place here is it will be a negative. And then the last part here, picking a number greater than 5, so 6. 6 minus 5, we get a positive. 6 plus 2 is positive. 6 plus 4 is positive. 6 minus 3 is going to be positive. And so our overall image right here is being positive. So now if I wanted to answer this function of when is it equal to 0, when is it greater than 0, when is it less than 0, we know that's going to equal 0 at our actual zeros. So that's going to be when x is equal to negative 2 and when x is equal to 5. We're going to have those two solutions there. Next one, when is f of x greater than 0? We're going to be looking at having when are our functions positive. So if I look at where do I have these positive symbols, we're going to look at those intervals. We're going to see one of the intervals goes for when x is less than negative 4. The middle interval goes from negative 2 to positive 3. And the last one is for the values of x that are greater than 5. And so there's our intervals for when our function is greater than 0. When is it less than 0? We're going to be looking at these last two functions. We're going to be looking for the interval from negative 4 to negative 2, as well as the interval from 3 to 5. And so that is how you are going to solve your inequalities. Now, you do not have to do the sign chart. If you find it's easier for you to graph out the function, which I would typically prefer, just because it's giving you a visual representation of what that function looks like, definitely do so. If you're struggling where your branches or where the parts of the lines go, sometimes the sign chart can help you out with that. I'm going to jump to a problem here that is going to be a little bit more difficult to kind of graph out. So I want us to just talk about this one in general. So here you're looking at a rational function of x minus 2 over the absolute value of x plus 5. We can still kind of have an idea of what's happening based off of the things that we've already talked about. The fact that our denominator here is the absolute value of x plus 5. We just have to be really careful because negative 5 is not going to be our only value here that's undefined. It's also going to, so negative 5 is going to be the value that we have undefined because that's the only place where we can end up getting our function to be 0. So negative 5 plus 5, that's going to end up giving us the absolute value of 0. Looking at where we actually have a 0, which is going to be at positive 2. So I can place a point here, and then here's where our 0 is. All right, so then we're going to break this up. We've got 3 different intervals that we're going to look for. So if I take a look at a value that's less than negative 5, like negative 6, negative 6 minus 2, well, that's going to give me a negative number. Negative 6 plus 5 is negative 1, but what's going to happen here is that your denominator is always going to be greater than 0 because the absolute value of anything has to be. So overall here we're going to end up with an interval that is negative. If I pick a number between negative 5 and 2, like 0, 0 minus 2 would give us a negative, and you're going to divide that by 0 plus 5, Absolute value of that is going to end up being positive, so our interval here will be negative. Pick something that's greater than 2, so I could take, let's say 3. 3 minus 2 is a positive. 3 plus 5 is 8. Absolute value of 8 is going to be a positive. Positive divided by positive is a positive. So then this whole area here is going to be positive for us. So answering our questions, when is f of x going to equal 0? Well, that's going to happen when x is equal to positive 2. When is f of x going to be greater than 0? We're going to have one interval, and that is for when x is greater than 2. When is f of x less than 0? And we're going to have two intervals here. We're going to have x is less than negative 5, and then we'll have the interval going from negative 5 to positive 2. It's not just one solid interval because at negative 5 we are an undefined value. All right, so I'm going to leave it there. Now you can work on your practice problems, and then following that you can work on your ACT.